A review on cryogenic rocket engine. Cryogenic engine. Liquid oxygen and liquid hydrogen as an oxidizer and fuel in the different mixtures or proportions are used. This mixture of fuels offers the highest energy efficiency for the rocket engines that produces very high amount of thrust. According to Newtonian third law of motion, rocket engine operates through force of its exhaust pushing it backwards. The materials with the most desirable properties are liquids only at cryogenic temperatures. Storing and handling the propellant in the liquid state is more effective than storing and handling the same mass of gas. Construction of this engine shown below. India's GSLV-D5 first cryogenic engine. Working. The propellants are pumped from storage vessels on board the vehicle through an injector to the combustion chamber. The propellant pumps are driven by a small turbine which is powered by bleeding off a small portion of the propellant flow stream and bypassing this stream to a gas generator. The fuel is usually passed through ducts in the nozzle wall to provide cooling before the fuel is injected. The fuel and oxidant combine in the combustion chamber to form products of combustion at high temperature and pressure. The products of combustion are exhausted from the nozzle at high velocity to provide the thrust for the vehicle. Problems associated with the use of cryogenic propellants. Low density of liquid hydrogen, more structural mass. Low temperature of propellants, complex storage. Transfer systems and operations. Hazards related to cryogens. Overall cost of propellants relatively high. Need for ignition system. Boil-off losses during storage on board vehicle. To avoid this problems, hydrogen is replaced by kerosene and LNG as fuel with same oxidizer oxygen. Semi-cryogenic engine. Semi-cryogenic engine replaces liquid hydrogen with refined kerosene, irosine as ISRO calls it. LOx will be retained as oxidizer. Kerosene is much lighter than liquid fuel and can be stored at a normal temperature. The kerosene combined with liquid oxygen provides more thrust to the rocket. It also occupies less space, which makes it possible to have more propellant in the fuel compartment tank. It is more environment-friendly, cost-effective, and more powerful compared to a cryogenic engine. It can carry a huge weight to a higher altitude. Dhawan engine. Dhawan engine is India's first private cryogenic engine developed by Skyroot Aerospace Company. It is used in Vikram launch vehicle, which can carry payloads up to 720 kilograms to the low Earth orbit. This engine is fully manufactured by 3D printer using superalloys, thus its manufacturing time is reduced by 95%. Tests are carried out and state that it worked till 20 seconds. In this engine, liquid natural gas and liquid oxygen used as a propellant. LNG has more than 90% methane and it gives high thrust, and it is considered as green fuel and rocket fuel of the future. Semi-cryogenic engine and Dhawan engine.